Good afternoon, everyone. So, in the last class, we discussed some of the topics. So, we discussed all these topics: applications of theory of computations, why to study theory of computation. Then we discussed what is alphabet, what are strings, what are the different functions on strings. Then we discussed one theorem for the reversal of the strings. Then we discussed relations on strings. We discussed substring, suffix, prefix. Okay. So now, in today's session, we are going to discuss more about language. So, defining a language. So, language is a recognizer. So, which decides whether or not a candidate string is in the language and returns true if it is and false if it is not. Okay. So, language decides whether a string belongs to the language or not. Then generator. So language is also a generator which enumerates the elements of the language. Okay. So rest of the points are not so important. So just you need to know what is language. Okay. So for language, there should be a recognizer which checks whether a given string belongs to the language or not, and also there should be a generator which lists all the strings belonging to the language. Okay. Next, sigma star. So sigma star is defined as set of all possible strings that can be formed from the alphabet sigma. So sigma star is a language. Sigma star is countably infinite. So consider sigma is equal to a comma b. So sigma star is defined as set of all possible strings that can be formed from the alphabet sigma. So with this alphabet, which and all strings can be formed? All of them, they belong to set sigma star. So epsilon, empty string, A, B, A, B, B, A, B, B. So we can go on writing the strings using the alphabet A, comma B. Okay. So all those strings, they belong to sigma star, which is a language, which is nothing but set of all those strings which can be formed using the alphabet sigma. Okay. So that's sigma star. When I say sigma star, it includes all the strings which can be formed using the alphabet sigma. Then defining languages. How to define a language? So set notation. So there are many ways to define the language. This is one approach. Language L is equal to W belongs to sigma star. So now you know what is sigma star. Sigma star is nothing but a language. It is a set of all the strings which can be formed using the alphabet sigma. So language consists of all those strings W which belong to sigma star, but there are some conditions which need to be satisfied by W. So only those strings which belong to sigma star and which satisfies the condition written here in the description, they belong to L. Okay. The another way of representing, so instead of writing sigma, we can write what are the symbols present in sigma. For example, if sigma is equal to ABC, then we can write A comma B comma C. So instead of sigma, I am writing all those symbols which are there in sigma. So description of W can take many forms but must be precise. Notation can vary but must precisely define. So here, while writing the description, it must be very clear, it must be very precise. There should not be any kind of confusion. Okay, because this description of W, it decides whether a given string belongs to the language or not. If description itself is not clear, it is not possible to decide whether a given string belongs to the language or not. That's why it is given here. Description must be very precise. Okay. Then see here, there are a few examples. So L is equal to X belongs to A comma B whole star. All A's precede all B's. So now you know that sigma is nothing but A comma B. So X is nothing but set of the strings which are formed using the alphabet A comma B, and only those X where all A's precede all B's belong to L. Okay. So see here, AAB is all A's precede all B's. AAA BBS, all A's precede all B's. AABBB. So in all these strings, all A's precede all B's. That's why they are in L. Now here BA, no, because B is preceding A. Then ABC, ABC, it doesn't belong to language because we are using C, which is not a part of the alphabet. We are supposed to use only A comma B. Strings must be formed only using A and B, and in the strings formed, all A's must precede all B's. Then only those strings belong to L. Okay. Then what about epsilon, A, AA, and BB? So what about epsilon, A, AA, and BB? So whether epsilon belongs to the language? Yes, Mohit. Whether epsilon belongs to the language? Yes, Mohit. Mohit is absent. Yes,
Present, sir.
present. Then give me the answer.
Yes, yes, yes.
Here, one language is there. What is it? L is equal to X belongs to A comma B star. All A's precede all B's. So here there are three strings which belong to L, and here there are few strings which are not in L. Now my question is whether epsilon belongs to L. What is epsilon? Yes, Mohit, what is epsilon? Yes, Mohit, can you hear me? Whose voice is breaking, yours or mine? You go to a proper place where there is proper network. Mohit. Yes. So whether epsilon belongs to the language. Yes, Anvit, whether epsilon belongs to the language. Yes, why it belongs to the language. Yes, yes, how you say that it belongs to the language. Epsilon is an empty string. Okay, so epsilon is an empty string, and empty string means there are no A's, there are no B's. So this condition is satisfied automatically. So if A's are there, then they must precede all B's. Okay, if A's are there, then they must precede all B's. That's why in epsilon you don't have A's as well as B's. That's why there is no confusion at all. That's why epsilon belongs to the language. What about A? Whether A belongs to the language, single A, whether it belongs to the language. Yes, yes, Ibrahim. Whether A belongs to the language. Yes, Ibrahim. Whether A belongs to the language.
Yes, sir.
Why it belongs to the language?
Don't
Yes,
know, sir.
don't know. See here, what is the condition? When all A's precede all B's, you say that string belongs to the language. So in A, there are no B's at all. That's why this condition is satisfied. That's why A belongs to the language. Similarly, AA, even here there are no B's. That's why even AA belongs to the language. BB, see here A's are not there. That's why there is no confusion. If A's are there, they must precede B's. Here A's are not there. That's why even this belongs to the language. Okay. So all of them belong to the language. Now, see next language L is equal to X. What is X? X is equal to YA. For each Y belongs to A comma B whole star. That is X is the string. X is the string which belongs to L. X is the string which belongs to L. But X is equal to YA, where A is a symbol. What is Y? Y is nothing but set of strings which are formed using A comma B. Okay. Now, can you give an English description for this? Someone, can you give an English description for this language? Yes, Anvit. Anvit, can you give an English description for this? Yes, Anvit, can you hear me? Y contains all the set of language of, a second, what is your, Y contains all the set of language of which X contains. X is a subset of Y. What is this? Very confusing. Y contains all the set of language of which X contains. X is a subset of Y. What you are saying? Huh? Not able to understand. See here, what do you understand from this definition of L? See here, one definition of L is given, which is very complicated, right? Which is very difficult to understand. That's why here this is a question. You need to give an English description for this. So instead of writing this complicated definition for a language, we can make it very simple. We can make a simple definition for L. So see here, L is equal to X. So X is nothing but set of the strings, and X is such that YA, X always ends with A. X always ends with A. So what can be the English description for this? L is equal to X. X belongs to A comma B whole star. In the description part, you can write L is equal to X belongs to A comma B whole star. So that can be the English description for this particular language. L is equal to X belongs to, instead of Y, I'm going to eliminate Y. Y is not at all required for the definition of L. So, so I'm giving an English description for this now. So now I'm going to write a simple definition for L. So this is very complicated, we can understand. So here from this also we can understand L is a language, X are the strings which belong to L. X is such that YA, so X always ends with the A. What is Y? Y is nothing but set of the strings which can be formed using A and B. So instead I can write L is equal to X belongs to A comma B whole star, and in the description part I can write L is equal to X belongs to A comma B whole star, and so there is some network problem, I think. Okay, facing some network connectivity problem. Okay, anyhow. So can you hear me now? Yes, can you hear me?
Yes, sir.
Okay, so I was discussing this example, right? L is equal to X for each Y belongs to A comma B whole star, X is equal to YA. So you need to give a simple description for this. Now this is complicated description. I want to write a simple description. So here, one second, I'll present. Okay, see here, this is a complicated description. I want to give a simple description for this. So here from this description also you can understand that L contains all those strings which are formed using A and B, and strings must end with an A. So those strings which are formed using A and B and which end with A belong to language L. Now, now how to make this definition simple? So now I'll write L is equal to X belongs to A comma B whole star. Okay, then X must end with A. So L is nothing but L is nothing but x, where x belongs to a comma b whole star, and in the description part I'll write x must end with an a. Okay, so L is nothing but set of all those strings which are formed using a and b which end with a. Okay, so description should be simple always. Description has to be simple. So now, Mohit, can you hear me? Yes, Mohit, are you there? Yes, now give one example for this language. Give one string which belongs to this language. The language what we discussed just now. Give one example for this particular language. Yes, make it fast. Yes, Mohit. So now you know what is the language. The language is nothing but set of the strings which are formed using A's and B's and which end with A. So give some strings which belong to this language. Yes, Anvit, give some examples. Give some strings which belong to the language. Language is formed using A's and B's and strings must end with A. Yes. A, B, A. This is an example. Okay. A, B, A is an example string because here you have only A's and B's and string ends with A. Okay. Yes, Mohit, now can you give one example? Yes, Mohit, can you give one example now? What you don't know, man? What you don't know? Huh? Then why you are attending class? See, here, what is the language? Language L is equal to, okay, L contains those strings which are formed using A's and B's and strings must end with an A. Okay, so let's see the next example. Let sigma is equal to A comma B. So alphabet is A comma B for all these examples. L is equal to W belongs to sigma star. Cardinality of W less than 5. Now you know what is sigma star. Sigma star is nothing but set of all those strings which can be formed using A's and B's. So W belongs to the set sigma star. That means in W you have only those strings which are formed using A's and B's, but only those W's belong to L where length of W is less than 5. Yes. Now yes, Amal, give an example for this language. For this language, give an example. The first one, cardinality of W less than 5. W belongs to sigma star. Give an example for this. Yes, Amal. Yes, Amal, are you there? Yes, give an example. Give an example for this language where length of W is less than 5 and W is formed using A and B. Yes, give an example. String formed using A and B, length less than 5. What is there to think in this? A, B, A. It is wrong because in this, in your example, how many symbols are there? 5. 5 symbols are there. Length must be less than 5. Okay. In your example, length is equal to 5. That's why it is wrong. Okay. If you eliminate one symbol, then this is a perfect example. Length should be less than 5. Mohit, Let's give an example. AAB is the right example because only A's and B's are there. Length is less than 5. Okay. Now, next example. W belongs to sigma star. W begins with B. W begins with B. Begins with B. Yes, some of you try to give some example. All of you can give. Few of you can give. No problem. In the chat box, you can type. Yes. What is it? W begins with a B. Yes. We have yes. In here. Some nice examples. Okay. So you can have string of any length, but only condition is that it must begin with a B. It must begin with a B. Now, now I'll ask one question with respect to the second language. Whether epsilon, whether epsilon belongs to this language, whether epsilon belongs to this language. Yes, clear answer in the chat box. Whether here I'm considering this language, W begins with B. Whether epsilon belongs to this language. Yes, Roshni is saying yes. Yes, what about others? Do you agree with this answer? Roshni is saying yes. Do you agree with this question? Okay. So here, my question is with respect to the second language. W begins with B. W begins with B. Whether my question is whether epsilon belongs to this language L. Epsilon means empty string. Whether epsilon belongs to L. Yes. Yes. All are saying yes. But the answer is no. But the answer is no. Why? Because what is the condition? W begins with B. If you say epsilon belongs to L, epsilon means empty string. How epsilon can begin with B? According to the condition here for the second language, every string must begin with B. Then only it belongs to L. In epsilon, you don't have A's, you don't have B's. It's empty string. Then how it can begin with B? How it can belong to L? That's why epsilon doesn't belong to L. Is that clear? Is it clear? Anvit, understood now? Okay. Now, now let me ask the same question for this first language. W belongs to sigma star. Cardinality of W less than 5. Whether epsilon belongs to L. Whether epsilon belongs to L. Yes, epsilon belongs to L because only condition is length should be less than 5. You know that epsilon is of length 0. 0 is less than 5. Condition is satisfied. And sigma star means what? Sigma star means all those strings which are formed using A's and B's. Which are formed using A's and B's. Even epsilon is a part of sigma star. Star means you can use A's and B's 0 or more times. You may use this A's and B's, you may not use. If you don't use, you get epsilon. If you use only A, you get A. If you use only B, B. If you use both A, B, and you can use them any number of times. You can write A, B, 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 A, B, B. So many strings. So sigma star includes all those strings which are formed using A's and B's by using them 0 or more times. Now, let's go to the third example. Okay, let's go to the third example. So, W belongs to sigma star. Cardinality of W less than 5. Whether epsilon belongs to L. Whether epsilon belongs to L. Okay, there is some. Okay. Can you hear me? Yes. Can you hear me
Yes,
now?
sir.
Some network problem today I'm facing. Okay, sorry for that. But I'm helpless. Okay. Can you see the slides? Can you see the slides?
Yes,
Okay.
sir.
Okay. Now I was discussing this third example. W belongs to sigma star hash b of w is equal to 2. Yes. Give some examples for this language. Give some examples for this language. Yes. So here BBAA. Any other example? BBAA. Yes. Any other example? ABBAA. Yes. All these are SBAB. Yes. All are right examples. What is hash? Hash B means number of times B occurs in W. That is, all those W where B occurs twice belong to L. So this is one condition. W must belong to sigma star, but this is not enough. W belongs to sigma star as well as number of B's in W must be equal to 2. Then only it belongs to L. Okay. Then only it belongs to L. So here in all these examples given, you have exactly two B's. Here also 2B, 2B. They can be anywhere. So you write a string using A's and B's, and if there are only two B's, then that string belongs to the language. Okay. Next one, L is equal to L is equal to L is equal to sigma star. Each A is followed by exactly two B's. Each A is exactly followed by two B's. Yes, Ibrahim, give an example for this. Okay, read the question. Each A is followed by exactly two B's. Each A is followed by exactly two B's. Okay, here Anvit is having some difficulty in understanding this hash. I'll get back to it later. Now, here, concentrate on this example. L is equal to W belongs to sigma star. Each A is followed by exactly two B's. Give some examples for this. Each, see, A is followed by exactly two B's. Ibrahim has understood in the other way. Each A is, here see this example, A followed by two B's, A followed by two B's. Yes, that is correct. Similarly here, yes, every A must be followed by two B's. See here, this is a good example actually. Here see B, it is beginning with B. There is a A. If A is there, it must be followed by two B's. Okay, yes, all are right examples. Okay, now, so you have understood each A is followed by exactly two B's. Now I have one question. I have one serious question for you. Mohit. Mohit is live now. Okay. Now, yes. Okay. Now, for this language, okay, okay, let me discuss this language because some are having, yes, Zida, Zida, can you hear me? Zida, where are you, Zida? Okay, I don't know. Okay, let it be. Now, some are having problem in understanding this hash. So here see third language L is equal to W belong to sigma star hash B of W is equal to 2. That is, you can write a string of A's and B's, but only those strings belong to L where number of B's, that is B occurs twice, exactly twice in this string. So if I say A, B, B, in A, B, B, how many times B occurs twice? Exactly 2 times. That means A, B, B belongs to L. If I say A, A, B, A, A, B, how many times B occurs? B occurs only once. B occurs only once. That's why A, A, B doesn't belong to L. So if I say A, B, A, B, in A, B, A, B, how many B's are there? 2. That means it belongs to L. If I say A, B, 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 in A, B, 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 how many B's are there? 3. That means it doesn't belong to the language. Number of B's must be equal to 2. Okay. Then only that particular language belongs to L. Is it clear now? One second. Yes. See here, this B subscript B indicates that occurrences of B in W. How many times B is occurring in W? Hash B of W returns how many times B occurs in W. So this is already discussed in previous class. Okay. So how many times B occurs in W is given by hash. So which must be equal to 2 for the strings to belong L. Is it clear, Anvit? No? Is it clear? Yes, Zida, why you are so late today? Zida,
Yes, sir. Yes,
why so
sir.
late today? Why late?
Network problem, sir.
Network now is it resolved?
Yes, sir.
Which network is that?
Wi-Fi.
Okay, okay, okay. Okay, I'll give attendance for half of the class.
Okay, sir.
Okay, now I have some questions. Okay, see, consider this language. L is equal to W belongs to sigma star hash B of W is equal to 2. Now my question is whether epsilon belongs to L. Whether epsilon belongs to L. For this language, whether epsilon is a part of this language is my question. Whether epsilon is a part of this language. The Anvit is saying yes. Others are saying no. Yes, Anvit. The answer is no, because according to the description, there must be two B's in the string, then only it belongs to L. If you consider epsilon, in epsilon there are no A's, no B's, then how it can belong to L? So epsilon cannot be a part of L because two B's must be there for a string to belong to L. Now, coming to the next language, L, each A is followed by exactly two B's. Each A is followed by exactly two bits, whether epsilon belongs to this language. Fourth one, whether epsilon is a part of this language. Each A is followed by exactly two bits. Whether epsilon belongs to language. Let's answer the present question now. Whether each, so whether epsilon belongs to this language, where each A must be followed by two bits, at least exactly two bits. Yes, tell me whether epsilon belongs to this particular language. Understood, right? This fourth language. Yes, give me the answer. Yes, yes, give me the answer. Yes, Pratiksha is saying yes. Where is the Shrestha? Shrestha is not at all responding. Yes, Sri Raksha is saying yes. What about Roshni? Is she offline now? Roshni, are you there? Yes, Prashanti. Prashanti. Prashanti, are you there? Prashanti. So, yes. So here, for the fourth language, epsilon belongs to the language. Answer is yes. Because see, if A is there, it must be followed by exactly two B's. If A's are not there, B's are not needed. That means epsilon belongs to the language. The next language, L is equal to W belongs to sigma star. W does not begin with A. W does not begin with A. W does not begin with A. Give some examples for this. W does not begin with A. You can give any example which starts with B. That's it. Any string which starts with B belongs to L because W must not begin with A. That is the only condition. Okay, so now you know how to define languages. I hope you understood this notation for defining the languages. Right. So now uh, whenever you encounter this kind of definition, you can clearly understand which and all strings belong to the language and which and all strings don't belong. Whether epsilon belongs or not can be easily identified. So that's why description has to be precise. If this description is not precise, then you cannot identify whether a string belongs to the language or not. So description has to be precise. These are few examples. Right. Next. Okay, now, okay. So, many question and answer session now. Be ready to answer. Okay, so what strings are in the following languages? L is equal to W belongs to A comma B whole star. No prefix of W contains B. No prefix of W contains B. Yes. Okay, Anmit is having doubt in the previous one. Okay, let's clear that. Can epsilon belong to L? One second. Here, you can view the chat box, right? Highlighted chat box, you can view, right? Yes, Anvit. Yes, respond. Highlighted chat box. Whatever highlight I do, you can see, right? Okay. So now, can epsilon belongs to this set? Okay. W does not begin with A. Okay, epsilon belongs to this set. Only condition is that W should not begin with A. It can be empty, or if it is not empty, it should begin with A. But only condition is that it should not begin with A. It can be empty. That's why epsilon belongs to the last language, this particular language. Okay. Now, okay, now we are in the first one. No prefix of W contains B. So for this, in the previous class, we discussed prefix relation. That must be clear to you. Then only you can give answer for this question. No prefix of W contains B. So if you have given the answer already, see, Roshni is saying no prefix of W contains B. This is wrong answer. This is also wrong answer. This is also wrong. This is also wrong. So all answers are wrong. What is the condition? What is the description? No prefix of W contains B. For this, I told you should know what is prefix. Okay, you should know what is prefix. No prefix of W contains B. Here, prefix means, let's go back to that slide. Let's go back to the prefix slide, prefix relations. Yes. Here, examples we see. The prefixes of A, B, B, A are, one is epsilon, A, AB, ABB, ABBA. See, these are the prefixes. These are the prefixes of string ABBA. Now, I hope prefix definition is clear to you. Right. Prefix definition is clear to you. So ABBA prefixes are epsilon, A, AB, ABB, ABBA. So see here, make a note of these prefixes. Now let's go back to the question. So no prefix of W contains B. Now can you give some examples? Yes, it is this thing. Only A's. Only A's. If there is a B, it will be a part of the prefix also. Say, let's consider this example. A second. Yes, all are giving correct examples now. Let's consider the wrong example. See here, AABB. See here, for this, epsilon is a prefix. Epsilon is a prefix. A is a prefix. AA is a prefix. AAB is a prefix. AABB is also a prefix. So in the last two prefixes, AAB and AABB, B is present. What is the condition? No prefix of W contains B. Prefix should not contain B. So prefix will not contain B only if B's are not there in the string. Okay, that's why string containing only A's. String containing only A's. Okay. Next. Next. Okay. Next. This one. Next exam. Next language. L is equal to W belongs to A comma B whole star. No prefix of W starts with A. No prefix of W starts with A. Can you give some examples for this? No prefix of W starts with A. Yes, no prefix of W starts with A. So these are the examples. That means every string must start with a B. So another way of saying that every string starts with B. No prefix starts with A. Okay, so when every string begins with B, automatically there won't be any prefixes which begins with A. Okay, no prefix of W starts with A. So these are the examples you can see here. So when string begins with B, condition holds good. That's it. Next example. One second. Okay. So next example. Okay, one second. Let's say what and all are there topics. Okay. Okay. So okay, I'll take one 2 minutes break. 2 minutes break. I'll take and I'll get back to you. Yes, Anvit. The notes already I mailed just when I started the session. Okay, Anvit, is it clear? Okay, okay, answer attendance now. Sushmita, just unmute and answer and mute it back. Acharya Sushmita. Yes, you can hear me, right? What is this, Anvit? Huh? Nonsense. Huh? Yes, Sushmita, are you there? Absent. Sushmita, Sushmita, absent or present? Sushmita, yes. Others,
Present, sir.
Aishwarya, Aishwarya,
Present, sir.
Akshata,
Present, sir.
Amal, 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 Amal,
Present, sir.
Anvit, Anvit,
Present, sir.
Archana.
Present.
See, Anvit, I mailed the notes to your group.
Yeah, the notification was off, so I couldn't see. Now I checked it.
Mm-hmm. Archana, Archana, Ashika,
Present, sir.
Ashwat.
Present, sir.
Okay, okay. Mute yourself. Atufa,
Present, sir.
Atufa,
Present, sir.
Aisha,
Present, sir.
Bhakti,
Present, sir.
Chirag,
Present, sir.
Chirag absent because you joined
Present,
just
present,
5 minutes back. 5 minutes back you joined. Okay,
present,
Chirag,
present, sir.
Chirag. No, I am marking you as absent because if
Present,
you
sir.
join just, huh?
Present,
When you
present.
joined, at what time you joined?
Half an hour ago.
Half an hour ago, just 5 minutes ago you joined.
No, sir.
Huh? No, it's
No,
next
no.
class I'm observing. If you continue, no, definitely next class I'll mark you as absent. Hari Prasad, Hari Prasad,
Present, sir.
Harshit,
Present,
Harshit,
sir.
Ibrahim,
Present, sir.
Kaushik,
Present, sir.
Kazi,
Present, sir.
Manisha.
Present, sir.
Ma- Manisha, you were absent yesterday, no? Manisha,
हाँ sir.
why?
हाँ.
Why absent yesterday?
Sir, network issue.
That you have to sort. Okay.
Okay, sir.
Hmm. Mohit, Mohit,
Present, sir.
who is this?
Present, sir.
Mohit,
Present, sir.
where are you, man? Where are you?
Present, sir.
Hmm. Lavanya,
Sir, where means Mumbai, sir.
Mumbai. Okay, okay. Lavanya, 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 absent. Faizan, Faizan,
Present, sir.
present. Okay.
Present,
Faik,
sir.
Faik,
Present, sir.
Hisham, Hisham, Hisham absent. Maulia,
Present, sir.
Nida, Nida,
Present, sir.
why absent
Present,
yesterday?
sir. I was not knowing, sir,
What you are not knowing?
that classes will start from September 1st. I was offline. I didn't knew. Later, I got to know around 12.
Okay. Pooja,
Present, sir.
Pooja, Prajwal,
Present, sir.
Pranav,
Present, sir.
Prasad,
Present, sir.
Prashanti. 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 I mark you as absent. Pratiksha.
Present, sir.
Pratiksha. Rifa. Rifa.
Present, sir.
Rohan. Rohan. Roshni.
Present, sir.
Roshni. Sahana. 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 Sai Niketan. Sangeet.
Present, sir.
Safa.
Present, sir.
Aranya.
Present, sir.
Chaitra.
Present, sir.
Shrestha.
Present, sir.
Sriraksha.
Present, sir.
Shweta.
Present, sir.
Siddharth.
Present, sir.
Sneha. 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 Present. Surya.
Present, sir.
Surya. Saurav.
Present, sir.
Yes, sir.
Srilal.
Yes, sir.
Srijit.
Yes, sir.
Srijit.
Yes, sir.
Suman.
Present, sir.
Suman. Sumant.
Present, sir.
Sunit.
Present, sir.
Sushma.
Present, sir.
Sushma.
Present, sir.
Smith.
Present, sir.
Sushmita.
Present, sir.
Sushmita.
Present, sir.
Darshita.
Present, sir.
Hima.
Present, sir.
Zida.
Present, sir.
Zida, at what time you joined?
At 2:45 something.
Okay, next class, if you repeat now, I'll mark as absent.
Okay, sir.
Altamash.
Present, sir.
Amreen.
Present, sir.
Bashiruddin. Bashiruddin. Sania.
Present, sir.
Rizwan.
Present,
Rizwan.
sir. Present, sir.
Okay. Just check if I marked you as absent. Just tell me. Sneha, Sai Niketan, and Sahana absent. Huh? Yes. Hello. Who is this? Huh? Hello. Tell me clearly, or else you type in the chat box at least. Prashanti present. Sahana present. Okay. Prashant, Sahana present. Okay. Then Prashanti present. Okay.
Present, sir.
Uh, Prashanti, you are not at all regular to the class.
Sir, I could send you a screenshot of showing network, sir.
Mm-hmm. Sahana, Prashanti, then Lavanya. Lavanya. Okay. Who else is present? Okay. Acharya, Archana, who is this? Isham, Rohan, Sai Niketan. Okay. Just mute yourself. If you have to say anything, just Archana present. Okay. Archana. Okay. 1 second. 60 are there. 4 are absent. 1, 2, 3, 4, 5, 6 are absent actually. Okay. Neha. Okay. Okay, I'll continue. Who is present? Okay. So let's continue. Let's continue. Okay. Let's consider the next example. So L is equal to W belongs to A comma B whole star. Every prefix of W starts with A. Every prefix of W starts with A. Let's give some examples. Third one, language is equal to W belongs to A comma B whole star. Every prefix of W starts with A. Yes. So whenever string starts with A, automatically prefix also starts with A. So another way of saying that every string must start with A. Okay. Every prefix must start with A. Both are same. Okay. So next one. L is equal to A power n, n greater than or equal to 0. Yes. Give some examples for this. L is equal to A power n, n greater than or equal to 0. A. Sneha Acharya. Present. Okay. So here n greater than or equal to 0. When n is equal to 0, what do you get? You get epsilon. When n is equal to 1, you get 1a. When n is equal to 2, you get 2a's. Like that, you can have any number of a's, including epsilon. So even epsilon belongs to the language. Okay, next, b a power 2n. Yes, now give some examples for this. b a power 2n. Give some examples. b a is the right one. Yes, few other examples. B, yes, B is an example because when n is equal to 0, you get a power 0. A power 0 means epsilon. You have b epsilon, which is nothing but b. So b belongs to the language. Next, you have b. Yes, ba doesn't belong to the language. This is wrong. Ba doesn't belong to the language. A always occurs as power of 2. That is, 1 second. Yes. See, when n is 0, you get a power 0, which is nothing but epsilon. So you get b. When n is 1, you get a power 2, which is nothing but a. You should write 2 a's. So b a. Then you have b followed by 4 a's, like that. Next you have b followed by multiples of 2, 6 a's. Then b followed by 8 a's, like that. Next, b power n, a power n. Can you give some examples for this? B, next one is b power n, a power n. See, for this particular language, epsilon doesn't belong because 1b has to be there. But here, epsilon belongs because when n is 0, you have b power 0, a power 0, which is nothing but epsilon. Okay, epsilon, then ba, bbas. So if two B's are there, 2 A's. Three B's are there, 3 A's. Like that, all such string belong to L. So these are few more examples. Okay. Okay. Say, uh, so there are a few more slides which, so okay, these slides starting from cardinality of a language, I'll skip for the time being and cover in the next class. Now, okay, I think there is no complexity, but still for the time being, I'll skip. I'll start with this finite state machine, FSM, very important concept. Finite state machine. Okay, so here just I'll do this one and this slide. Two slides I'll do today, and after that I'll end. So finite state machine. Finite state machine. So computational device having a string as input and having one of two possible outputs, that is accept or reject. So finite state machine is a computational device having a string as input and having one of two possible outputs, either accept or reject. So here, this is the, so here, incoming arrow indicates start state. So here, so finite state machine is a computational device having a string as input and having one of the two possible outputs, either accept or reject. So incoming arrow indicates start state. So here there is incoming arrow which indicates that Q naught is the starting state. Double circles accepting state. So whenever you have double circle, they are accepting states. So Q naught as well as Q1 are accepting state. So single circles rejecting states. So wherever single circle is there, that is rejecting state. Okay. Time required is less than or equal to length of the string. Okay. Now uh, just you need to remember that finite state machine is a computational device which accepts string as the input and which gives two outputs, two possible outputs. Output can be either accept or reject. So here incoming arrow is indicating that Q naught is initial state. Double circle indicates that Q naught and Q1 both are accepting states, and single circle indicates that this D is an rejecting state. So you remember this much for the time being. Then, so as I told, vending machine is an example of automated hardware which are developed using automata theory. Okay. Now, one second. So, drinks in a vending machine cost rupees 25. Okay, so there is one vending machine which is dispensing cool drinks, and cost of a cool drink is 25 rupees. And this vending machine accepts rupees 5, rupees 10, rupees 25 coins. So you have three types of coin: 5 rupee coin, 10 rupee coin, 25 rupees coin. First, you need to insert coins, push drink button. Drink is dispensed if enough money. So you need to insert one coin. You need to press on drink. If money is sufficient, he'll get the drink. Okay. Language. String of coin sequences adding to rupees 25, allowing drink to be dispensed. Okay, so Q is representing 25 rupee coin. So Q belongs to the language. If you insert Q, that is 25 rupee coin, and press drink button, you'll get the drink. That means Q belongs to the language. Otherwise, if you insert DDN, what is D? 10. N means 5. So 10, 10, 5 is again 25. Now you press drink button, you'll get the drink because DTN also belongs to the language. N, 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 D. N means 5, 5, 10, 15, 10, 25. Now also you should get the drink. So S is representing pushing of the drink button. Okay. S is representing pushing of the drink button. Now this is the FSM for the vending machine, which will dispense the drink whenever sufficient amount you have inserted. So now see, initial state is yes, incoming arrow indicates the initial state. So S is the initial state. So S is representing pushing of the drink button. See, right now vending machine is in state yes. If you push yes, if yes means pushing the drink button. If you press that yes button, there is no change in the state. There is no change in the state. Now let me go straight way. Don't look at other branches. What is N? N means 5. So if you insert 5 rupee coin, it will come to the state 5. If you insert another 5 rupee coin, it will come to the state 10. If you insert another 5 rupee coin, it will come to the state 15. Another 5 rupee coin, it will come to the state 20. Another 5 rupee coin, it will come to the state 25. 25 is an accepting state, as you can see, double circle. Now if you press yes, you'll get the drink, and amount becomes 0. You go back to the initial state. So when you are in state 25 right now after inserting 5 rupee coins. Now if you press yes, yes means drink button pressed. What happens? You get the money. So 25 will become 0. That means machine is in the initial state now. Okay. I hope this much you have understood. Is it clear? Understood this much? Yes. Any doubts in this till here? Yes. Any doubts till now? Yes. Any doubts till now?
No, sir.
Yes, Anvit, what is your doubt? Anvit, what is your doubt? Yes. What is this? Yes, no. Yes, no means. Huh?
No doubt, sir.
What about others? Let me check. Let me ask questions to few of students. Yes, Anvit, you are saying something? Anvit, are you saying something?
No doubt, sir.
Yes, Chirag, are you there? Chirag? Chirag, are you there? Yes, Chirag. I'm going to mark you as absent. Okay. Chirag, you're not there, right? Okay, no problem. Mark you as absent. Okay. Mohit, Mohit, are you there? Mohit. Mohit, are you there?
Yes, sir. Yes, sir.
Yes. Okay. Mohit is there. Have you understood till here? Mohit, have you understood till here?
Yes, sir. Yes, sir.
Chirag, network problem. Hmm? Don't give justification for your mistakes. Okay, I marked you as absent. We will see in the next class. Okay. So now string of coin sequences adding to rupees 25. So here, initially vending machine is in state yes. So when you add 5 rupee coin, it comes to 5. Another 5 comes to state 10. Another 5 15. Another 5 20. Another 5 25. When amount is 25, if you press button, get the drink and machine goes back to the initial state. This is one possible way. Now here in state 5, if you press button, you'll not get the drink because insufficient amount. Machine remains in the same state. In state 10, if you press yes, no change, same state. In state 15, if you press yes, no. 20 press, you don't get the drink. Okay, that's indicated by self loop. Now, see, there are many branches. Okay, but very simple example. See here, initial state, if you insert Q, you directly go to which state?
Sir,
Sir,
State 25.
presentation
There
is
is
not
another
visible, sir.
possibility.
sir, present.
From state yes to 10 after inserting
Sir,
10
sir,
rupee coin.
presentation
10
is
to
not visible, sir.
25. 1 second. It is a mistake. 10 to 20 it should be after inserting another 10 rupee coin. Yes, Anvit. Anvit. What? Why?
Sir, the presentation is not visible, sir.
What is this? What happened? Yes, Ibrahim. What is this for?
Presentation, sir.
Yes, I mentioned clearly.
Now it's
If you
visible,
write like
sir.
now, is it visible now? Now it's visible. Yes, for 1 minute it
Yes,
went
sir.
off because of the network problem. Hmm? If you write sir means what I can understand.
Yeah.
Huh? Okay. Now see here. Now visible, right? Yes, visible right now. Now you are not speaking. Now it's visible now.
Yes, sir.
Yes, sir.
Okay. See here.
Yes, sir.
Okay, okay. See from yes to 10 after inserting a 10 rupee coin. 10 to 20 after inserting another 10 rupee coin. That's a mistake. Okay. From 20 to 30 after inserting another 10 rupee coin. Now you are in state 30 after inserting three 10 rupee coins. Now if you press push button, you'll get a drink, but for drink 25 rupees. 5 rupees is still there. That means instead of making a transition back to the initial state, you make a transition to the state 5 because 5 rupees still there in your account. Out of 30, only 25 is utilized for the drink. 5 rupees still there. That's why transition is back to 5. So this is how This is the finite state machine representing the working of a vending machine. Okay. So I hope with this example you have understood the working of a finite state machine, how it can be used for designing of automated hardware. Right? Is that clear? Yes, Anvit, is that clear? Okay, so with this I'll end for today. Okay, I'll start with the remaining topics in the next session. Okay, so you can leave now. Thank you.
Thank you, sir.